Okay, I'd like to talk a little bit more about why I think the term single phase is not good. It's crap. I think it should be called single cycle. You can see my previous video to bring yourself up to speed, but let's continue. Let's go a little bit deeper. And please be patient. I'm just trying to keep this simple, succinct, and sensible. I'm not an electrician. I'm not a professional in any field. I just like to share ideas. Maybe someday someone will actually say, oh, I get it, and maybe even use those ideas. That'd be pretty cool. So single phase isn't just referred to as single phase. Sometimes they call it split phase or dual phase. So let's look at these terms and see if they make any sense. Single phase. Okay, I already talked about that. All right. No, the single phase is not a good term for that. Because we know, and I showed clearly, there are two phases, A and B, in each cycle. Okay? I showed how there were two distinct phases in one cycle. And you can see on your cycle graph, you can see that. So two phases make one cycle. And you don't even have to call them phases. You could call them half cycles. Okay? We talked about that. So a phase is a distinguishable part in a course or a cycle. It's a distinguishable part in a course or a cycle. Phase A and B, I showed, are easily distinguishable. Okay? The cycle is not distinguishable. The cycle can be repeating. It can be identical cycles repeating over and over and over. And we know they do because it's called current. It's alternating current. So we know that. So as far as my proposal, my theory goes, there's nothing contradictory so far in what I've said. Now you say, well, it's really split phase. Let's call it that, and everything will be just fine. Well, no, it won't. Split phase is crap too. If phase A and phase B equal one cycle, you could use the phrase split cycle, okay? But not split phase. You see, you could say split cycle, but not split phase. It wouldn't make any sense. Neither phase in our cycle, excuse me, neither phase is split. If either of those phases were split, you'd have a phase of a phase. If either of those phases were split, you'd have a phase of a phase, which is stupid. So you say, oh, well, what about the split phase in relation to the transformer? Maybe that's what people are saying, okay? So let's say you have, this is a primitive drawing, very basic, very primitive. You have a secondary coil in your transformer. All right, let's say you have this. And you say, well, we're using the term split because we're looking at this transformer diagram, right? Okay. So what are we given? What do we have here? Well, your neutral service conductor, all right, that's tapped in to your coil, all right? The neutral taps the coil. It doesn't split the coil. It taps into the coil, doesn't split it. The coil remains intact. The coil remains available and it's live. You would say hot, but live's a better word. It's a live coil. You're not splitting the coil, all right? You're tapping into it at a distinct point. None of the 240 volts, okay, across your two legs, all right? None of those volts are missing, okay? So even if you had, let's say this is very primitive, three-phase, that's what they call a three-phase transformer, very primitive. This would be your delta. All right, let's say we had that. Okay, keep that in mind. Even with one coil of a so-called three-phase transformer tapped, you wouldn't refer to any part of that configuration as split. You wouldn't call it that. Even if you were talking about that so-called three-phase, that's a crappy term, three-phase. Even if you did this with your neutral service there, you still wouldn't call it split. People don't do that. And you say, well, Joey, you're an idiot. You're not an electrician. You don't know what you're talking about. I went to 4 places here in the town I live in central Pennsylvania, professional establishments, professionals who work on people's electrical stuff and do all kinds of stuff, and none of them understood what I was saying. So I could be really, really wrong. So they say, oh, no, don't worry about that. It's actually called dual phase. It's dual phase. That'll clear up your thinking. I said, okay, let's look at dual phase. To be fair, let's give it a shot. Can you call it dual phase? Yes. If you're referring to one cycle only. Yes, there's 2 phases here, dual. You could do that, but that refers to one cycle only. Yet even if you use the term dual phase, you're still dealing with single cycle service. The service is single cycle. If you have a so-called 3-phase service, you would not refer to it as triple dual phase service. That's idiotic. Oh yeah, it's dual phase, but I switched over to 3-phase, so now I have triple dual phase service. This is hideous. See, if you really look into it and break it down, you'll see that the terms that have been used for about 138 years here in America are really crappy. Just crappy, and I'm going to change them, starting with single cycle to replace single phase. We start there, we move on and get into some really good stuff. Okay, now, remember, in any given moment, that's like a snapshot of current. In any given moment, current flows in one direction only through one conductor, and one direction only in any given moment. Now, here's where people get into trouble, and I'll explain it. Let's say you have a cycle graph. You can find this on the internet all over the place. People say, this is dual phase, this is split phase, whatever they call it. And then here's the transformer picture they use. They use this picture here, and they say, okay, here we got current going this way, and we got current going that way. It's very simple, right? And they justify this graph by looking at this. Well, you can't do that. It's an illusion. Current flows in one direction only in a single conductor. With single cycle, you would call it single phase service. The event shown in the cycle graph, this does not happen. You can look at it all over the internet all you want. Under Google Images, it doesn't happen. Unless, well, how can it happen? The event in the cycle graph, the event here in the cycle graph, okay, time, this is time, okay? You see here, time goes this way. And right away you see a problem. You say, if time goes that way, what's going on here at the same time in a single conductor? Nothing. Oh, yeah, you could call it an explosion or a fire or a death. Anyway, the event in the cycle graph to happen requires 2 conductors. The transformer event here needs only 1 conductor. This needs 2 conductors to happen. This needs only 1. And why? Because it's an illusion. It's theory. It's a thing somebody wrote on a piece of paper. And I just did it. But here's what really happens is, you see this secondary coil here in your transformer out there on the pole? If you look at that coil and you put your see your leg here. All right, let's say it's black. You put it here like this. You just turn that leg. Current goes this way, goes through the coil. There's no neutral, there's no tap. It just goes through the coil and it goes out the red. It's all going in the same direction as one single conductor. This looks like you have two conductors. Yes, you do. Technically speaking, you have two different colored wires, but you don't have two different circuits. This would require two different power sources, two different conductors. So here's the problem, and I can remedy this in the next few videos. We shouldn't be focusing on the terms black wire, black conductor, red wire, red conductor, or hot A conductor, hot B. We shouldn't be focusing on that because it throws us off. We should use the concept that I call send return. See, I'll explain this, and I'll explain why some of these illusions, in theory, they look good on the internet. You can see graphs everywhere, and numbers and volts and all kinds of crap. But that doesn't change what's happening in your electricity. Now, that sounds a little goofy, but please be patient because I'm going to explain this as we go deeper. You might say, oh man, that actually makes sense. So thanks for being patient, and we'll see what happens.